One is N2O, right? And this the other one is NO, N2O3, N2O4, and N2O5 as well. They form 5 different compounds, right? So one is nitrous oxide, nitric oxide, dinitrogen trioxide, dinitrogen tetroxide, dinitrogen pentoxide. So if you take the ratio of mass, ratio of mass of nitrogen to that of oxygen, right? That is the what mass of N to the mass of O. So what is that in the first case? What is it? 28 is to 16. In the next case, it is, come on, 14 is to 16. Next case, 28 is to, come on, this is 48. 28 is to, this is 64. And this is 28 is to what? 80. Clear or not? 80. How? So the mass of nitrogen is 14, mass of oxygen is 16, atomic mass I am talking about. There are 2 atoms, means 2 into 14, 28. 1 atom of oxygen, 1 into 16 becomes your what? 16. Clear or not? Here 14, here it is 16, right? 1 atom of nitrogen and 1 atom of oxygen. Now see, in all 5, out of all 5 compounds, in which compound, tell me which are the compounds having the same mass of nitrogen? Which are there are 5 compounds. Which are the compounds having the same mass of nitrogen? Huh? Which are the compounds having the same mass of nitrogen? Oh, is it? Same mass. Which are the compounds having the same mass of nitrogen? N2O, N2O3, N2O4, N2O5, right? The same mass of the nitrogen. But this compound, the mass is 14. 14 can be written as, can I write 14 as to 16 as 20 is to 32? Yes or no? The mass of which element is fixed right now? Nitrogen. What is it? 28. So keeping the mass of nitrogen fixed, right? And the mass of which element is different? Oxygen in all those compounds. So keeping the mass of nitrogen fixed, if you take the ratio of the masses, right? The ratio of mass of nitrogen in the compounds. So what is it? 16 is to 32 is to 48 is to 64 is to, what is that? 80. We are keeping the mass of nitrogen fixed, that is 28 in all those compounds, right? The mass of oxygen is different. In that case, we take the what? Ratio of masses of oxygen in all those compounds. So what is the ratio? What is the simplest ratio? 16 is the SCF. So it is 1 is to 2 is to 3 is to what? 4 is to 5, which is a simple ratio. It's a very simple ratio, right? So the law states that, what does it state? When 2 elements combine to form more than 2 compounds, the different masses of one element which combine with the fixed mass of another always bear a simple ratio with one another. We have seen this. Yes or no? So another law is what? Law of reciprocity. Talking about another law, reciprocal proportion. Right? What is it? That is again related to the What is the law of reciprocal? Law of reciprocal proportion, what does it state? What is the law all about? Right. The ratio between the masses of two elements A and B, right, which combine with the fixed mass of another element C, always, be the same, or the multiple of ratio in which A and B directly combine together. So what is that? The ratio elements like A and B, which combine, which separately the ratio between the masses of two elements A and B, which separately combined with, what, a fixed mass of third element C, always be in the same or multiple ratio, in which, what, multiple of ratio, in which A and B directly combine together. So what does it mean? Right? To explain this, I am taking the help of an example. I am taking three elements like carbon, hydrogen, and oxygen. Right? Carbon, hydrogen, and oxygen. Three. See, try to understand. The ratio between the masses of two elements A and B, which combine with the fixed mass of, which separately combine with the fixed mass of third element C, always be in the same or multiple of ratio in which A and B directly combine together. So let me explain this. Suppose, we are taking three elements like carbon is one, hydrogen is another, oxygen is another. Like this, we are we are representing, right? We are representing three elements at three different vertices of a triangle, right? So one is carbon, the other one is hydrogen. The three elements we are taking. So when hydrogen and carbon and hydrogen, they combine together. So what do they form? CH4. Carbon and hydrogen combine together, they form what? CH4. When carbon and of ratio in which A and B directly combine together. So we are taking here A this one, hydrogen, B as this one, and C as carbon, right? See this, why? See, this is what is the ratio of mass. We're taking the ratio of, you know what, mass of carbon and hydrogen. What ratio? Mass of ratio, that is we are taking mass of carbon to that of mass of hydrogen. Kisme le? So yes, in CH4 we are taking. In CH4, if you are taking this ratio, CH4 compound is CH4, we are taking the ratio of mass. So what is that? Carbon is, hydrogen is 4. 12 is to 4. Yes or no? And in case of carbon dioxide, the compound carbon dioxide, right? The mass of, you know what, carbon, that ratio of mass, carbon to mass of, to that of mass of oxygen, mass of oxygen, right? If you are taking that, so carbon to the what, the mass of oxygen, this is 12 is to what, 32. The atomic mass of carbon, you know what, carbon is 12, atomic mass of oxygen is 16, what, 32. Yes or no? So keeping the, you know, keeping the mass, which element is carbon in CH4 and carbon dioxide. If you take the ratio of mass of hydrogen to oxygen to that of, you know, if you take the ratio of mass of hydrogen to that of ऑक्सीजन, कार्बन का मास को फिक्स रखना है, किसका रेशियो लेना है, मास ऑफ हाइड्रोजन का मास और ऑक्सीजन का मास का रेशियो लेना है. देखोगे क्या हो रहा है, मास ऑफ H रेशियो मास ऑफ O. So what is that? 4 is to 32. That is 1 is to 8. Understood? 4 is to 32. That is 1 is to 8. Right? And now, so the law states, one part of the law is this one. The ratio in the masses of two elements A and B will separately combine with the what fixed mass of a third element C. So we have taken three elements like, you know, carbon, hydrogen and oxygen. Then when carbon combines 4 in CH4 and in CO2, we are taking the ratio of mass of what, carbon to that of oxygen. It is 12 as to 32. So the mass of carbon in both the compounds is fixed. So fixing the mass separately, that they are directly combined together. When they directly combine together, what do they form? Yes, H2O. When they directly combine together, they form H2O. Yes or no? So in that case, the ratio of mass, what is that ratio of mass? Ratio, that's mass of hydrogen to that of what? Mass of oxygen. What is it? 2 is to 16. That is 1 is to 8. Now that is the same. 1 is to 8 here, 1 is to 8 here. So when they directly combine together, that is, you know, the ratio is the same. The ratio between the masses of two elements which separately combine or multiple of ratio combine, you know, they directly combine together. When they directly combine together, the ratio is 1 is to 8. And here we fix the mass of carbon and we have taken the ratio of either will be the same or multiple or the ratio in which they directly combine together. So when H and O they directly combine together, they form H2O and the ratio of mass is 1 is to 8. So this is again, this is the fourth law that is related to the what? The mass, and that is the law of chemical combination. Again, the fifth law is which one? It is related to the volume. Gay-Lussac's law. Lewis law of combining gases volume. So what? Okay. What is Gay-Lussac's law of combining gases volume? So when gases combine, they do so in when gases combine, they do so in volume, which bear a simple ratio with one another, and also with the volume of the product if they are in the gaseous state. Right here, all the measurements are made under the similar condition of temperature and pressure. So what does it mean? When the gases combine, they do so in volume, which bear a simple ratio with one another, and also with the volume of the product if they are in the gaseous state. Here, all measurements made under similar conditions of pressure, temperature, and pressure. When gases combine, they always combine in volume, and they bear a simple ratio with one another, and also with the volume of the product if they are in the gaseous state. And here, whatever the measurement, suppose we are measuring the volume of all gases, and all the volume are measured under similar condition of temperature and pressure. So let me explain with the help of an example. Like uh, here, hydrogen is a gas, so also chlorine is a gas. When they combine, they form hydrogen chloride gas, right? So hydrogen is a gas and chlorine is a gas. And hydrogen chloride also, it is in gaseous state, it is also a gas, right? So when gases combine, they combine in volume, the first part. So here, what is the stoichiometry in terms of volume? One volume. Here, one volume, right? When gases combine, they combine in volume, which bear a simple ratio with what? One another. So if you take the ratio of volume, the ratio of volume for both the gases, so what is it? 1 is to 1, which is a simple ratio. It's a very simple ratio. And also with the volume of the product, either if the product is a gas, right? So whatever the product, what is the state of the product? It's also a gas, right? Now if you take the ratio of volume for the reactants and the product, so it becomes 1 is to 1 is to 2. 1 is to 1 is to 2. That is, it is also a simple ratio. Understood? When gases combine, gases means hydrogen and chlorine, these are the gases. When they combine, right? When they combine, they always combine in volume according to this law. So here clearly the stoichiometry, says one volume of hydrogen we are taking, and it combines with, one volume of chlorine to form 2 volumes of what? Hydrogen chloride gas. When gases combine, they combine in volume which bear a simple ratio with one another. When they combine together, in which ratio they combine? 1 is to 1, and 1 is to 1 is a simple ratio. And also with the what? The volume of the product, if the products are in the gaseous state. So the product is also, this is only one product we are getting, that is in gaseous state. Now you have to take product into account. Now the ratio of the volume of the reactants and the product is 1 is to 1 is to 2. Again, it's a very simple ratio, not complex one. And here all in the volume is measured under the similar condition of pressure and temperature. That is one condition, right? So suppose pressure is measured at P, temperature is measured at T. For hydrogen, the same pressure, the chlorine gas is also measured, that volume is measured at the pressure P and temperature T. Same thing happens with what? The SCl. Clear or not? Another example I am also giving you so that I can explain about this law. N2 plus S2 gives us what? 2NH3. So N2 plus 3S2. It's a valence chemical equation right now. Right? Yes. Tell me here how many volume of nitrogen we have? How many volume of nitrogen? 1. How many volumes of hydrogen we have? Hydrogen 3. So 1 volume and here 3 volume. Yes or no? So ratio of volume of reactants when the gases combine. So nitrogen is a gas, hydrogen is also a gas, ammonia is also a gas. When gases combine, they combine in volume. So if you take the ratio of volume of reactants, so what is that? It becomes what? 1 is to 3. That is a simple ratio. A simple ratio. It's a simple ratio. And also with the volume of the product, if the products are in the gaseous state, ammonia being a gas, right? So you have to take the the volume of the product into account while taking the ratio. So ratio of volume right now, when you include the product, the ratio of volume of reactants and product, it becomes 1 is to what? 3 is to 2, which is a simple ratio again. And here all the measurement, all the volumes are measured under the similar condition of what? The volume of is measured under the similar condition of what? Pressure and temperature. Understood? Understood? So this finishes law, law of what? Chemical combination. We have discussed 5 different laws, right? So I hope all of you have understood all the 5 laws. Any doubt? Nothing. Okay, let me wind up this session. Thank you very much.